Annual windstorm losses X and Y in two different regions are independent and each is uniformly distributed on 0 to 10. Calculate the covariance of X and Y given that X plus Y is less than 10. So now, if this condition was not given and they were just asking you covariance of X and Y, then that would be 0 because X and Y are independent. But the problem is that we are now stuck with this condition, and therefore now we have to work out what it is. So the region with the given condition, so the given condition is X plus Y is less than 10, and the initial region is X between 0 and 10 and Y between 0 and 10, because both X and Y are uniform on 0 and 10. Okay, so the region with the given condition is, so maybe we can make a note of this. Since X and Y are uniform, X, Y are both uniform 0, 10. So we have X between 0 and 10. Remember, uniform 0, 10 means the density is 1 over 10 when X is between 0 and 10. Okay. And so if the condition was not there, then the region would be a square, 0 to 10 on each side. But now we have this condition that X plus Y is less than 10. So the X plus Y equals to 10 is this line. So X plus Y less than 10 would be this region. So the whole blue region. Okay. And we have to find covariance of xy given X plus Y is less than 10. So normally you know that covariance of xy is E of xy minus EX EY. But this time we'll have E of xy given X plus Y is less than 10 minus E of X given X plus Y is less than 10 times E of Y given X plus Y is less than 10. Now, to get these expected values, we have to get the corresponding PDF, conditional PDF. Since the densities of both variables are uniform, so the conditional density is also uniform and equals the reciprocal of this area. And the area of this region is the area of this triangle, half base height. So both sides are 10 and 10. So half 10, 10, that's 50. So therefore the conditional density is 1 over 50. X between 0 and 10, Y between 0 and 10, and this extra condition that X plus Y is less than 10. So E of X given X plus Y is less than 10 would be the double integral of X against this conditional PDF, X against 1 over 50. And now let's understand the region. If you go dy first, then you have to go a vertical strip and y is 0 in the bottom of the strip, and on the top of the strip y is 10 minus x from this equation. So y goes from 0 to 10 minus x, and x goes from 0 to 10. And now it's x times 1 over 50. 1 over 50 can be pulled out. The integral of dy, x is a constant, so the integral of dy is just y, so x times y. Y goes from 0 to 10 minus x, and you put in the limit, you get x times 10 minus x, so you can multiply it out, so that's 10x minus x squared. And the integral of that is 10x squared by 2, which is 5x squared minus x cubed by 3. And that'd be 500 minus 1000 by 3. When you put in x equals 10, the lower limit is 0. So this comes out to be 10 by 3. And now the region is completely symmetric with respect to both variables. See, completely symmetric. Doesn't matter which way you are looking at it. And therefore, the expected value of y given x plus y is less than 10 will be equal to expected value of x given x plus y is less than 10. So that they're both 10 by 3. So now we're just left to find e of xy given x plus y is less than 10. So now we double integrate xy against the conditional PDF. So xy times 1 over 50. Same limits as before because the region is still the same. So the integral of y is y squared by 2. 1 over 50 can be pulled out, and the integral of y is y squared by 2. X is a constant when you're doing it with respect to y. So this 2 multiplies with this 50 to give 100. So 1 over 100, x times, and then you put in the limits for y, 10 minus x whole squared, and the lower limit is 0. And you open up the 10 minus x whole square, that's 100 minus 20x plus x squared, and then you multiply the x. So that's 100x minus 20x squared plus x cubed, and then you integrate. This is 100x squared by 2, so 50x squared minus 20x cubed by 3 plus x4 by 4, 0 to 10. And you substitute the limits in the end, you get 25 by 3. And now we have everything. Covariance would be the e of xy, which is 25 by 3 minus exey, 10 by 3, 10 by 3. And again, all the values are conditional. So when I said e of xy, I meant e of xy given x plus y is less than 10, this one. And the same for the ex and ey. And this ends up being negative 25 over 9. That's choice B. Remember, variance cannot be negative, but covariance can be negative.